Now I'd like to talk about a different kind of factoring. We've already talked about factoring by greatest common factor. Now I want to talk about factoring, it's called by grouping, okay? Now, there's something you need to understand by grouping. 4 terms. You must have 4 terms to factor by grouping. If you don't have 4 terms, factoring by grouping isn't going to work. So, as a matter of fact, when you see 4 terms, after you try common factoring to all of them, grouping is probably the way to go. As math teachers, things are somewhat contrived, so you see 4 terms, try common factoring, and then go to factoring by grouping right away. Okay? So, anyway, I've got 4 examples written up here. Sorry, 4. 3 examples written up here. I've got 4 on the brain. Each of these examples has 4 terms. So, hence, you'll start to see right away. All right. Try greatest common factoring by pairs of terms. Okay? I capitalized the P here. I guess technically it's supposed to be small. But you want to do it by pairs of terms. A pair is 2 terms at a time. After that, you check to see if you can factor with greatest common factoring again. It's like you're using greatest common factoring twice in a row. Now, I'm going to admit to you, this last one looks a little weird. You'll get used to seeing it when you're doing factoring by grouping. Okay? So now, we do take a quick glance. Is there anything that I can factor out of all 4 of them? We do glance for greatest common factoring every time. I got x, x, x. I don't have any x's. I've got a 1 here. As soon as you have a 1 in front of any term, excuse me, as soon as you have a 1 in front of any term, the greatest common factor is 1. So there's nothing you can divide out of all 4 of them. All right, so let's look at them by pairs. Just the x to the third and the negative 4x to the second. Is there anything that I can factor out of both of those? And the answer is yes. I can factor out an x to the second. This has a 1 and a 4, so there's no number, but I can use the lowest exponent. So I can factor out an x to the second there. And when I divide, I'm going to write that a smidge lower. When I divide both of these by x to the second, my leftovers, and that's what goes inside the parentheses, that's going to be x minus 4. Now let's look at the second pair. I have a 3x and I have a negative 12. Well, I can't get any variables out of there, but I can divide both of those by 3. They both have a 3 in common, don't they? So I'm going to write, and I'm going to use positive 3, so I'm going to use plus 3 there. And then inside the parentheses, that's what happens in common factoring. After you divide it, they go on the inside. The 3's cancel there, leaving me an x. Negative 12 divided by 3, that's negative 4. Now, I said try greatest common factoring by pairs, so we did it the first pair. And then check to see if you can factor with greatest common factor again. Well, x squared and 3, they're not the same. But x minus 4, these 2 terms are both being multiplied times x minus 4. So using greatest common factor, x minus 4 is the greatest common factor because it's common to both of these. As a matter of fact, it's the only common factor. And then, if we follow through with our GCF, we divide both of these by x minus 4. Now the reality is you're not even going to bother writing this. You're going to see right away that the x minus 4's cancel, and my leftovers that go in the parentheses behind are x squared plus 3. Now, right away, people start to realize, hey, if they got the same thing in the parentheses, is the stuff, the terms that are written in front, go in their own parentheses behind it. So you'll get used to seeing that with factoring by grouping. All right? So let's look at the second one. I got 5x plus 15 minus ax minus 3a. Is there anything that they have in common that you can factor out of all four? The answer is no. Yeah, I got it. Well, I'm going to do it by pairs now. So I got 5x and 15. I'm going to put a line here, because this here was the correct answer for the one above. Sorry, I'm working so close together. So 5x and 15, I can divide a 5 out of both of those. So when I divide by 5, that leaves me x plus 3. And on negative a and negative 3a. Now, we do need to look a little bit ahead. They both have an a, don't they? If I just divide out the a, and I just pull out a positive a, that's going to leave me, when I divide by a and divide by a, the a's will cancel, and it'll leave me negative x minus 3. Now take a look at this. X plus 3, negative x minus 3. These are identical, except the signs are different. What if I divide out a negative a? So if I pull a negative a out of both of them, well, a negative a divided by the a's cancel, and negative divided by negative is positive, will leave me with an x. And again, negative divided by negative is a positive, and the a's cancel, leaves me with a 3. That makes it so what's inside the parentheses on these is the same. And I'm not going to bother writing it all out. As we saw up here, if you've got two things in parentheses, you got numbers in front, you can just write the x plus 3 and the 5 minus a. Okay, for my last one, 2y to the second minus 8y plus y minus 4. There's nothing we can divide out of all of them. So on the first one, I'm going to pull out a 2y. So when I divide by 2y, because that's the greatest common factor, and divide by 2y, I'm left here with, the 2's cancel, a y. 8 divided by 2 is, negative 8 divided by 2, that's negative 4, and the y's cancel there. But now when I look at my second one, I've got another y minus 4 there, don't I? Wait a minute. Mr. Trapp, there's nothing you can divide out of that. That's true. Now this is a little bit tricky, but if you ever get a match down here, keep in mind that 1 times y minus 4 is still y minus 4, isn't it? I have y minus 4, so I've got plus 1 times y minus 4. Now we've got the y minus 4's both in parentheses. This is a little bit of a special case. But if you get it where you have a match, you're allowed to put a 1 in front of it. So now I've got my y minus 4, and outside of the parentheses is 2y plus 1. Anyway, that is factoring by grouping. 4 terms. If you don't have 4 terms, it won't work. You're really just doing greatest common factor twice in a row. Good luck.